We'll proceed in vector and commercial calculus. Vector and commercial calculus. Vector and energy calculus. Okay, so that is a kind of better word in saying vector and energy calculus. Okay, vector and energy calculus. So in that sense, we are finally land up into calculating the energy. This kind of explanation is not available anywhere. So it would be a matter of surprise that what is energy and vector and this and that. Okay, generally people calculate energy in a term of scalar value only. This much joule, that much joule. I have a battery. Okay, no, no, where is battery? I had a battery. Okay, I have a battery and somewhere I had a battery. Okay, I have very big battery. This is my homemade power bank. Okay, this power bank has very powerful, very powerful 694 13 battery. It has 13 batteries. It is extremely powerful. It takes 36 hours minimum to charge with the high power charger. And one cell, if I talk about one cell, okay, now I don't know how much it is, but if you see any kind of power bank, then it would be written or set of battery if I take, it would be written as 10 milli 10,000 10,000 milliampere hour. That is the power of the battery. 10,000 milliampere hour. Okay, if I consider power bank, I'm not talking about the battery. Consider this is a power bank. There are two things here. One thing is it's like an atom bomb. Okay, one thing is there are two things here. One thing is battery, and another thing is the it is open now. It's not closed one. So another thing is this electronic circuit. So there is electronic circuit and there is a battery. Electronic circuit is two-way. If you push 5 volt, then it will convert to some other volt constant current and then it will charge the battery. Now battery is 3.7 volt. It passes through the same electronic circuit and comes out as 5 volt. If I consider the power of power bank, not the set of battery, then 10,000 milliampere hour. Okay, 10,000 milliampere means 10 ampere. Someone can draw 10 ampere of the current at 5 volt for 1 hour constantly, and after that it is gone. Okay, then what is the kind of there is something called energy and something called power. Power is how much joule someone can withdraw in 1 hour. Okay, so in that sense, 10 ampere into volt, 10 ampere current into volt equal to power. Current into volt equal to power. So if it is like that, then it is 10 into 5, 50 watt. 50 watt. 50 watt for 1 hour means 1 hour. If this this power source is 50 watt, 50 watt means at 5 volt 5 volt 10 ampere can be withdrawn in 1 hour. Next hour again 5 volt 10 ampere can be withdrawn constantly. For next hour again 5 volt and 10 ampere current can be withdrawn constantly for 1 hour. If that is the case, then it is 50 watt, 10 ampere into 5 volt. 50 watt is the power of this battery. But if it is written 10 milli 10,000 milliampere hour means someone can draw 50 watt only for 1 hour. Okay, power is hour basis. After 1 hour it will be zero. Okay, if someone is withdrawing instead of 10 ampere at 5 volt, if someone is withdrawing 1 ampere of the current at 5 volt, then it will go for 10 hours. If someone is withdrawing 100 milliampere for 100 milliampere at 5 volt, then it will go for 100 hours. Okay, whatever it is, energy computation is considered as the most perpetual means more permanent than going for here and there calculation. That's why we are saying vector and commercial calculus, vector and energy calculation through the calculus, mind blowing, amazing. Okay, now in that scenario, now what we have seen as far as a Green's theorem and curl factor and this and that, what so many things we tried, right? Like what is the energy? What is the energy calculation? If I have a fire, if I see a fire, what is energy calculation? Immediately I'll calculate the temperature, how much temperature it is raising. That gives a hint how much energy it is liberating, how much joule of energy it is liberating. Okay, someone can store energy like a battery, capacitor. People store energy out there. Okay, that is the energy. Energy is this is okay. I have a fire and energy. The computation of the energy is because of the temperature of the fire. Okay, I have one item, I have one item, and from the earth it is height h. What is the energy of this? Then energy computation will come as m, that is mass of this, g is acceleration of the earth, and h is the height. Same energy. Here also it is joule, there also it is joule. When we are talking about fire, then energy computation is coming through temperature. If I am talking about potential energy, if I am talking about potential energy, the energy calculation is happening through the height, acceleration, and mass. If I am talking about something in speed, it also has energy. If on ground, earth ground, if I roll something, then height is zero. Someone will say there is no energy, mgh, h is zero, no energy. But there is a, because of speed, there is energy. Okay, this battery neither has temperature. Okay, if someone has a speed, then energy is mv square, mass into velocity square. Now this battery, it neither has temperature, nor it has a height, it can be kept on the ground, nor it has any velocity. Does it mean that it does not have energy? It has energy. But energy measurement is different. In fire, energy measurement is through the temperature of the fire. Whereas something in velocity, then energy measurement is through the velocity. If someone is velocity, then energy measurement is through velocity. If someone is at some height, then energy measurement is through height. If something is in fire, the energy measurement is through temperature. If something is like this, then how someone can measure the energy? Okay, in that sense, he has to calculate voltage, current, he have to pass the current through a resistor and then calculate the energy. Energy is same everywhere, joule. Energy is same, but it is changing different, it is making different forms. Everywhere the form is different. Here it is called electrical energy that is stored there. In fire it is called heat energy. If I keep at some height, it is called potential energy. If I make it moving, it is called kinetic energy. There can be infinite type of energy. Okay, so as per Sir Albert Einstein, if you go in calculating the energy, if you focus on energy, irrespective of the shape it has taken, energy can take any shape, in any form, then that will be better calculation than you run with the speed and height and here and there. Okay, in that sense, if I have a force, the example we are giving, the example we are giving, consider I have an energy source. Consider I have energy source. I have energy source, that is some energy source is kept, some magnet is kept here. And because of the magnet, there is a force, magnetic force. Because of the magnet, there is a magnetic force. Because of the magnetic force, one item that deflect because of magnetic force is deflecting from one position to other position. If there is a big magnet kept here, I am hiding it. I have. Consider that I have a very big magnet kept here. Because of the big magnet, there will be a magnetic field. Because of the magnetic field, if I keep a wood, then there won't be any deflection. But if I keep another magnet or if I keep a magnetic material like iron, then certainly it will have deflection. If it has deflection from point A to point B, then magnet is working. Deflection happened because of the magnet. Magnet is losing energy in moving the item from point A to point B. How much energy it lost moving the item from point A to point B? Okay, how much energy, how much joule? Consider that. Consider, consider the kind of what is wattage of this energy source. What is watt of this energy source? Watt of this energy source is 50 watt. 50 watt. 50 watt means in 1 hour it will lose 50 joule of energy. That is 50 watt. 50 watt is the power of the magnet, means in every hour maximum it will lose 50 joule of energy. What is the wattage of a bulb? Means every hour, if it is 100 watt, 100 joule of energy in 1 hour it would consume. It will take. If a dynamo has capacity of 1 kilowatt, 1 kilowatt, 1 kilojoule of energy in 1 hour it would liberate. Okay, main thing is energy. If same amount of energy is liberated in less amount of time, the wattage is more. What means energy by time? What means power means energy by time. Same amount of energy. Okay, I am earning 10,000 rupees. I am earning $10,000. I am earning 10,000 ruble. Now two people are standing. One person is earning 10,000 ruble. One person is earning 10,000 ruble. Both are earning 10,000 ruble. If both are earning 10,000 ruble, then what is the next? If someone is earning 10,000 ruble, then anyone would keep quiet. Okay, nice, thank you. You are earning a lot. If someone is earning 10,000 ruble, another is earning 10,000 ruble, the next question someone will ask, you are earning 10,000 ruble in how many days? Okay, now this guy is saying, I earn 10,000 ruble in 30 days, in 1 month time period. This guy is saying, I am earning 10,000 ruble in 1 day. Both are collecting energy of 10,000 ruble, but one is in 30 days, one it is in 1 day. Now, as per energy calculation, both stand at same level because they are both are gaining 10,000 ruble energy. Energy is like that. Energy is quantity. Power is not quantity. Power is in how much time. So this guy who is earning 10,000 ruble, the guy earning 10,000 ruble, they have same energy, but power is different. This guy earning 30 days, power is less. This guy is earning in 1 day, power is more. Okay, that is the equation of the power. So, but anyway, power, force, momentum, this and that all come and go. Main thing is energy that can never go. It changes its form. One form of calculating energy is force into displacement. One form. Where if there is a magnetic field because of one magnet source is there and one item is deflected because of the magnetic field from here to here, it is attracted toward the magnet from here to here. How much is the work done by the magnetic field, not by this guy? Because this guy just got attracted. Someone is pulling it. If someone is pulling it, that guy is losing energy. How much joule it is losing when item is moving from here to here? Okay, that is force into displacement. Whatever the magnetic force is into displacement, that much is the energy that magnetic field is losing. Okay, now another question we saw If energy lost by magnetic field is dependent only upon the one point and another point, then this magnetic field is called path independent. It does not matter this guy moved from here to here in a straight line or in a circular line, in a parabolic line, in an elliptical line, doesn't matter. Begin point and end point only matter in calculation of the energy lost by the energy source. If that is the case, then it is called path independence energy source. If it is dependent upon the path, then from point A to point B, if it takes straight line, the energy lost by the energy source is different. If it takes circular path from same point to same point, energy spent is different. If that is the case, it is called path dependent. How much it is path dependent? Okay, how much it is path dependent? If it tends to independent, little bit it is path dependent, but more or less it is independent only. We have covered it. In that sense, from point A to point B, or it takes straight line or circular line, any line, little bit difference is there. If there is a vast difference between straight line and circular line and elliptical line, then it is highly path dependent. Highly path dependent. Otherwise, it is less path dependent or it is completely path independent. How much it is path dependent? That is the question. How much it is path dependent depends upon the curling factor. Hop, hop, hop. This is what mathematician brought. Two things they saw in the behavior of any magnetic field. Okay, one thing they saw, if it is path independent, if someone says, I am path independent, my energy source is path independent. It does not matter what is the path the item is traveling under any force field. What matters is the begin point and end point. Okay, begin point and end point, right? Means if my begin point and then end point are same, it begin and then in a closed loop it came back to the same point, then your energy spent from the energy source is zero. Yes, because begin point and end point are same. Energy lost is by the energy source is same because is zero because it is path independent. If it is path dependent, then it matters that in what path it is traveling, not on the position, begin position and end position. If that is the case, now idea was to calculate the nature of the path independent energy source. What is how much it is path dependent energy source? How much it is path dependent? It is dependent, it is path dependent. To what extent it is path dependent? To very little extent it is path dependent. More or less it is independent only. To high extent it is path independent. So, then very less extent it is path independent. Otherwise it is path dependent only. How much it is path dependent? Then people calculate is okay. You want to know how much it is path dependent, right? So take a point here and make a closed loop, a path and come back to the same location and see how much energy that energy source lost. Divide it by the area, it forms an area, right? If I do like this, then it forms a circular area in between. This is a circular line around which the item is moving, but behind the scene it made a disk, circular area, two-dimensional area, closed area. Okay, area is closed, one area. Okay, now it is called that calculate the energy consumption that happened moving an item in a circular path or any closed loop path from point A to A. Okay, under the force field, let it move in a circular path. If it moves, now calculate how much energy the energy source has spent. That energy divided by the area of the closed region, that is the nature of this energy source, because that is now path independent. If the path is very big, then energy spent by this guy is more because it is path dependent. If path is big, the energy spent by energy source is big. If path is very small, then force into displacement. Energy spent by this is less. Path is bigger, energy spent is more. If I divide it by the area, means bigger path means division is bigger. Small path, division is smaller. Even a smaller path, division is smaller. If I take a staircase of thing, then a staircase kind of area will come into the picture. Net, we are normalizing it, more or less. If you see three-dimensional graphics, then three-dimensional graphics, then whatever the value of RGB we take, that is normalized value from 0 to 1.0, not 250 and 1000 and 1 lakh and 100,000, that is not bother. What is between 0 and 1? Tell me your value. This is called normalized value. My value is infinite, I don't care. Tell me from 0 to 1, I don't care your infinite and this and that. Similarly, if energy consumption from the energy source for the path dependent, if item is moving from point A in a closed loop, again coming back to point A, how much is energy spent from the energy source? If that energy spent from the energy source is X, divide it by the area. This is called energy density, circulation density, and this factor is independent of the path. If it is independent of the path, this factor talks about the nature of the path dependency of the energy source. Okay, someone would say, if you don't divide it by area, if path is small, the energy consumption is small. Then I don't know what is the nature of energy device. If path is bigger, the energy consumption is bigger. It no the path distance is path distance. The length is bigger, energy computation is bigger. Okay, means path length is now controlling the net energy consumption. Path length. Path is bigger, energy is bigger. Path is more bigger, energy is bigger. I'm not able to get the nature of the energy source because it is completely controlled by the length of the path. Force is same. Okay, if that is the case, now divide it by the area. Keep its mouth shut now. The mouth of the displacement, keep its mouth shut if you divide by area. If you divide it by area, if you say, okay, my path is very big, now okay, divide by big. Now, the dependency on the length of the path is over. Now, silently, I can monitor what is the dependency factor of the energy source. So, if I have energy calculation in a closed loop divided by area, that is the nature of the how much the path dependency factor is in the energy source. Another factor of this is through Green's theorem. Green theorem is saying that energy calculation for a particle that is moving from point A and coming back to point A, it forms a closed loop. And whatever is the area is, there is one area. If someone is moving in electrical path and coming back to the same path, this region is ellipse. If this region is ellipse, then Mr. Green is saying that calculate the curl factor. Curl factor will calculate the curl factor, torque factor. Calculate the curl factor that is arising because of the energy source and then integrate it with dx dy, that is the xy plane. We are talking about two dimensions right now. So whatever is the torque factor, integrate it by dx dy over the closed region. If I integrate something with dx and dy, okay, if I have a curl factor is if I have a point A and point B, if item is moving from point A to point B, okay, in some direction, either it is in a kind of arc direction, straight line, or whatever it is, these two movements from point A and point B can be considered as energy calculation would be force and along the line, force into displacement, force along the line when it is reaching from this point to this point. It is same as I calculate the energy from this point to this point in vertical direction and this point to this point in horizontal direction. Considering this length is very small, tends to 0, delta. If it is delta, then whatever we are talking, these are tangent. If I'm trying to calculate the energy movement, if I'm trying to calculate the energy movement, energy calculation from this point to this point, consider these 2 points are very near to each other, delta r. If this path is r, then delta r. If that is the case, delta r from this point to this point, then at this point I can have a tangent like this. At this point I can have a tangent like this, and this point I can have a tangent like this. Okay, means I can, what I'm trying to say is, if it is very small, this section is very small, I can consider a straight line. Okay, I believe I can do it even better. If this is a very straight, this is a one point, this is another point. This is very small, delta r, very small. If it is like a circle, if you take a circle and take 2 points in the circle and it is very small, if it is very small, they will tend to behave like a straight line that is tangent at that point. If it is tangent at this point, then this tangent at this point can be described as one vertical line and one horizontal line. Okay, that is the to form a triangle. Now, what if point A to point B item is moving from point A to point B, then one path from point A to point B is one path is vertical and another path is horizontal. If I talk about the force field has two components, F1 and F2. There is a vector called force field vector F. F equal to F1I plus F2J. Now, if this is the path, then F1 will apply here. F1 is the component along x-axis. Force field F equal to F1I plus F2J. F1I, I is x-axis, J is y-axis. This is y-axis right now. F1I plus F2J. If this is the line along which the item is traveling, okay, actually item is traveling from here to here. I made two paths. I dissociated into two paths. If I take this path, then F1 will come to the picture, that is along the I vector. If F1 is same, if I go along this, then there is no dF1 by dy, then it will push it. If there is a dF1 by dy, as we change in the y, F1 is changing, it will make a torque. Similarly, in this path, if there is F2 in this direction, if F2 is same along the x-axis, it will push it. Otherwise, if dF2 by dx is there, it will make a curling. Now, this curl and this curl, they will try to nullify each other. If they are able to nullify it, then there is no torque as far as the because of the force. Force dF2 by dx is the torque that is along this direction. dF1 by dy is the torque along this direction. If dF2 by dx minus dF1 by dy equal to 0, then they are nullifying each other's torque. They are nullifying each other's torque. Means this force field is not generating any torque. If force field is not generating any torque in the path, means this is considered as path independent. The force field, if it does not generate any torque, someone can go even deep in this. This much I could do. So if the force field is not generating any torque between point A and point B, or point A comma B and point alpha comma beta, if an item is moving from point A comma B to point alpha comma beta because of a force field, then and it is moving straight way without any movement like this, okay, like earth is a energy source. If I leave it is dropping exactly like this. It is not rotating like this. It is because earth field is not, earth field is path independent. If it is path independent, it will not create any torque. If it is path dependent, then it will create a torque. It will start rotating. If under any force field, item is moving from one position to another position and it is rotating while moving, then it is called path dependent. This proves that this is it is not dependent upon the begin point and end point. It depends upon the path also, because the curling factor along the line is there. This is the other way people have started thinking about the path dependency. More curling tendency of an energy source is, more it is path dependent. If it is there, if curling factor of the energy source is 0, then it is not path independent. It is not. It is path independent if it is 0. Means from point A and point B along the path, if dF2 by dx, the curling factor like this, curling factor like this, dF1 by dy, curling factor by like this, if they nullify each other at each point, means force is path independent. Force has nothing to do with the path, because at each point in the path, the both component of the force F1 and F2, they are nullifying each other. Then it is not dependent upon whatever path you take. Understandable, right? If you take a straight line, then they are nullifying each other. If you take if you make it part into small section, in each section they cancel each other. If you take a circular path, again in each section they cancel each other. If you take a parabolic path, elliptical path, staircase path, maze path, a zigzag path, every moment they are cancelling each other. If they are cancelling each other at every moment, means net effect is zero, means it is not dependent upon the path. Okay, there is better proof for this, that we have seen if it is path independent, the net energy calculation is F1 dx plus F2 dy. That is G. If dg by dx is F1, dg by dy is F2, then it is path independent. We have seen it. In that sense, dg by dx dy is df1 by dy. dg by dy dx is df2 by dx. dg by dx dy, dg by dy dx are same for path independent. That's why df2 by dx minus df2 by dx minus df1 by dy is 0. That is mathematical proof. But anyway, this is people now saying if it is path independent, net curling factor, the curl it generates is 0. Otherwise, if curling is there, how much curling is there? That is the scope of path dependence. As per Green's theorem, if someone is trying to calculate energy spent by the energy source, when item is moving from point A and coming back to point A in a closed loop, the energy spent is whatever is the curling factor, integrate it along the xy plane, and then the limit is the area it is making. So if some item is moving from point A and making a circle and coming back to point A, it is making a circular region. If it is a circular region, then equation of the circle is x square plus y square equal to A, that A square, that is the radius of the circle. Y equal to square root of A square minus x square. Okay, if that is the case, then the net energy computation is curling factor df2 by dx minus df1 by dy, integration along xy plane, and then the limit is x is minus a to a because it's a circle, minus a to a, and y is minus a square root of a square minus x square to square root of a square minus x square. Okay, that is the net energy calculation. Whereas, as per the normal fundamental, net energy calculation is force vector dot d of position vector. If force vector is F1i plus F2j and position vector is xi plus yj, net energy calculation is F1 dx plus F2 dy. In circulation density, whatever the energy calculation in a closed loop divided by the area. Okay, same thing here, the circulation density now as per the Green theorem is calculate the energy and divide it by the area. Same thing. If that is the case, then integration over the area df2 by dx minus df1 by dy, that is the curling factor dx dy. Whatever the energy computation is, divide it by the area, it becomes the circulation density. That is the nature of the energy source. Okay, but you are talking about a nature of the curling factor means df2 by dx minus df1 by dy. Here only f is involved. That is also talking about the nature of the energy source, right? There is no path involved here. df2 by dx, all right. df1 by dy, all right. df2 by dx minus df1 by dy. This is the nature of the energy source. Why we are talking about calculate the energy df2 by dx minus df1 by dy curling factor integrate over xy plane, that is dx dy, and limit is the circular region, whatever the closed loop region. That is net energy. Why we are calculating net energy when we know that the nature of the energy source can be computed through df2 by dx minus df1 by dy. Hold on. Hold on. Okay, keep your nerve tight. Okay, now energy calculation through Green's theorem is in a limit, in a closed limit. The integrand is df2 by dx minus df1 by dy, and then the differential is dxy plane or dx dy. This is net energy calculation divided by the area. As per the circulation density formula, calculate the net energy, divide it by the area. Okay, now whatever I am going to talk now, it is not available in any of the book, any of the online material, whatever it is. Okay, now if someone watches it closely, the Green's theorem in two dimensional, the limit is over the closed loop area, two-dimensional area. That is the integration. First is limit, and then Integrand is df2 by dx minus df1 by dy. It will come as an algebra. It will come as an algebra. This algebra, consider it is fxy. This algebra is fxy, function over xy, and then dx dy. This is a typical example of calculating volume of a surface whose equation is fxy. fxy, fxy, z equal to fxy can be z. Z equal to square root of a square minus x square minus y square. Or fxy equal to square root of a square minus x square minus y square dx dy. This is typical example of calculating volume of a sphere. If there is a fxy function is there algebraic function over x and y, and if we are calculating the doing the integration over xy plane, this is a typical example of calculating volume of a surface. That surface is represented through fxy and integration over a xy plane. This is a surface, 3D surface, and 3D surface is kept like this. I'm trying, if I do whatever the function of this 3D surface is fxy dx dy, integration over a region. Now, if I see from the top, then it forms a kind of rectangle here, forms a kind of rectangle, forms a kind of rectangle. If I calculate the fxy dx dy and integrate over this rectangle, it will give me the volume of this, not volume of this, underneath whatever the air is, or I can keep it centered at the origin, or I can just keep it on the xy plane. If that is the case, then if I do the integration in this rectangular region of this fxy, it will give me the volume. This is a typical example of calculating the volume d2 df2 by dx minus df1 by dy dx dy. It will come as algebraic equation dx dy integration over the 2D area on the xy plane. If that is the case, what is the equation? How we calculate the volume of any item? If I have 3D item, okay, if I have a 3D item, how I can calculate the volume of the item? I really have a 3D item. Okay, I have better 3D item. Okay, I have I have 3D item. Okay, what is your 3D item? This is my 3D item. I believe this is called musk melon. Nowadays summer has started, so musk melon are there. This is musk melon, and this is melon. Okay, watermelon. Wow. It would be minimum 5 kilogram. It is very heavy. Okay, so this is one melon, and this is musk melon. Okay, if that is the case, then we are trying to calculate the volume. If I'm trying to calculate the volume, this I can keep. Okay, if I'm calculate the volume of this is the surface. Now, if I take any small region on the xy plane, if this is the surface, if this is the surface, then I take any, if I see from the top, it is a circle here. In this circle, in the, whatever the intersection circle it is making, in the circle, let's take one small region, delta x, delta y. Take one delta x along the x-axis, take delta y along the y-axis. Delta x, delta y. Now, if you see the delta, this is xy plane, and here I took one square region, one rectangular region, delta x and delta y. From that, if I go and map, it will hit one height. If it is kept here, it will hit one region in the surface. Okay, one curved region in the surface. One curved region in the surface. If I see down, then there is a rectangular region. Remember, there is a region on the surface. If I see down, then it is a rectangle. It is a rectangular region. Similarly, I cut a small section here so that if I see from the take out that section, if I see the down, it is a rectangular region delta x delta y. What is volume of this? Consider delta x delta y is an area. Then delta x delta y into the height. That is the volume. Volume of any if consider delta x delta y tends to very small. If it is very small, otherwise all along z will be different. Understandable, right? If I take a curved region, if I take a curved region, if I take a curved region, this is delta x and this is delta y. Then everywhere z is different. You see, everywhere z is different in this rectangular region. If it is very small, then z will be only 1. Now, what is volume there in that infinitesimal small volume area? Height into the area. X, delta x into delta y into height. Okay, what I'm trying to say is now chop it into 100 section. Every section has delta x and delta y along the x-axis, y-axis, and height is z. Now, each section, if you calculate volume and add it, it will become volume of this. Chop it into like the way we do in 2 dimensions. In 3 dimensions, chop it, first chop it like this in xz plane, chop it like this in yz plane, chop it like this in xz plane, chop it this in yz plane, chop it. Now bring that cubical section, okay, whose width is, whose xy axis is delta x, delta y, and height is only z because it's very small. Like that, if you chop every part, now if you now set if every part, if you assemble together, every part, whatever the volume is, if you add, it will become volume of this melon, musk melon. Okay, in that sense, the one volume is z, that is fxy delta x delta y. Now the summation of what, how many part you have done, n equal to 1, summation I equal to 1 to n, that much part someone had cut it. I equal to 1 to n fxy fxi comma yi. At every section, what is fxy, what is z, delta xi delta yi, ith delta x and delta y. If you keep adding all, it will becomes the volume. Okay, that moment only. Now I divide it by okay, now I divide it by delta x delta y there only, then it becomes fxy only. If I divide it by delta x delta y at that moment only, then it becomes fxy only. Okay, if it becomes fxy only, if you make the summation, doesn't make any sense, only fxy will remain. Means if you cut it into infinitesimal small section, each section volume each section volume is fxy delta x delta y. If you add everything, it becomes summation I equal to 1 to n, where I equal to 1, summation sign I equal to 1 to n. Okay, f function xi comma yi, delta xi delta yi. If you add all the cubical section, it will become the net volume, that is equal to fxy dx dy integration limit over the region, summation of f xi comma yi, function over xi comma yi, delta xi delta yi, and summation is I equal to 1 to n. If you add everything, this is, if delta x tends to 0, delta y tends to 0, this will typically becomes integral calculus, and that is fxy dx dy, and integration over a limit, a closed loop. What I am trying to say, you can go with reverse fashion also. Reverse fashion of integration over a circular, over a closed area, integration or limit over a closed area fxy, the algebraic function dx dy can be written as summation of I equal to 1 to n fxi comma yi delta xi delta yi. Now, in this form, when it comes in this form, now this is nothing but summation of each volume. I have cut into n part, each volume summation, that is equal to dx dy, what we saw. Now, and each section is fxy delta x delta y, each section. Now, in each section you divide it by delta x delta y. If you divide it by delta x delta y, then they will delta x delta y would cut each other. Delta x and delta y would cut each other. If they don't cut each other, then numerator becomes the integration, and denominator, that is delta x delta y, that is again summation, becomes the area. Makes sense? If each section is fxy delta x delta y, and there just divide it by delta x delta y. Okay, just divide it for fun, divide it. Now add for each section. If you add, the numerator will become integration fxy dx dy, and denominator delta x delta y, if you add for each section, it will become the cross section area. Make sense? So this is nothing but the numerator is integration and denominator is cross section area. That is what is the we are trying to calculate. That is the numerator become energy calculation as per the Green's theorem divided by the area. That is circulation density. Now go in delta x delta f form. X form. Okay, it is understandable. In Green's theorem, it is saying, through Green's theorem, if I want to calculate the circulation density through Green's theorem, if we are trying to calculate circulation density, then energy computation in a closed loop divided by the area. Energy computation in a closed loop is integration over the xy closed region fxy dx dy divided by the area. If I cut into many sections, then divide by the area becomes delta x delta y, summation I equal to 1 to n. Numerator becomes summation I equal to 1 to n fxi yi delta xi delta yi by summation over I equal to 1, summation over I equal to 1 to n delta xi delta yi. Makes sense? Now keep one summation only. Then delta x and delta y, they cut each other. What will remain is fxy. Fxy we have taken through the curl only. This curl will come out if someone calculates the circulation density through Green's theorem energy formula. Then it is integration over the closed loop, that is the limit fxy dx dy, that is the energy calculation divided by the area. If someone goes in the intricate way, then the area dx dy, and here the area, they cut each other in the smaller section region, and what comes out is the fxy function over the x and y, and that is nothing but the curl factor df2 by dx minus df1 by dy. Means circulation density, what we calculated, the energy calculation in a closed loop divided by the area, is nothing but df2 by dx minus df1 by dy. That is the curling factor torque tendency. This is amazing and mind blowing. Means path dependency nature, how much energy source is path dependent, we can just calculate through df2 by dx minus df1 by dy. This is 2D. In 3D, we will see. Okay, now we learned that if I know the torque tendency of an energy source through torque tendency, we can understand how much it is path dependent. Mind blowing. So the proof we have provided that the how we got the curling factor as the path dependency nature calculation, that is the circulation density, is nothing but the Green's energy calculation in a closed loop divided by the area, and that is nothing but it comes as the curl factor, only df2 by dx minus df1 by dy. We will proceed on this. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.